It's time for Pure
Performance. Get your stopwatches ready. It's time for Pure Performance with Andy Grabner and Brian Wilson. Hello, everybody, and welcome back to Pure Performance. This marks episode number 8, so we're all happy for that. I am Brian Wilson, and as always, to the left of me, or to the right, or virtually in the ether, is my co-host, Andy Grabner. Hello, Andy.
Hey, well, it's actually a good question. Left, right, or in this case, across the pond. I'm sitting in lovely England, and believe it or not, it's sunny.
Oh,
wow!
Crikey! Should we do the whole? Should we do the whole show in? I can't. I can sometimes do a pretty good English accent. I just can't do it right now. I was going to do the whole show in an accent, but I'm just not even hitting it right now. So forget it, mate. It's Australian. See, I don't even know what's going on. You know why? Because it's 9:25 in the morning for me right now. That's why.
There you go. Hey, who else do we have on the line today? Who is the guest of honor?
We have someone who used to be a colleague of mine at Dynatrace. By title, we were equal footing, although he was always much more brilliant and bright than me. But now he's gotten recently a promotion, so he's a big fancy higher up. So welcome to the show, Mr. Mike Villiger.
Hey there.
Hi, Michael. Why don't you tell us a teeny bit about yourself there?
So my Dynatrace story is a long and entangled one. Obviously, as some of you might, if you go off Google and my name and my relation to Dynatrace, I was actually a customer for a couple of years. I've spoken at nearly every Perform conference I've participated in one way or another. And, obviously after coming on board, I worked with Brian for a couple of years in our product specialist group. And now I'm working in strategic business development, kind of working on a lot of our cloud partners.
Cloud partners. So, Mike, I think I just recently saw you, and maybe I'm jumping too far ahead, but I saw you presenting at the Cloud Foundry Summit. Is that right?
Yes. So at the Cloud Foundry Summit, I was able to give a lightning talk about performance metrics-driven continuous integration and continuous delivery, which is a topic that's near and dear to your heart, is it not, Andy?
It is. No, I love it. And I like it that you bring it into, obviously into the cloud era, and that is also the topic I think that we want to talk about today, right?
Correct.
Yeah. Although the sun is out in jolly old England, it is going to be a cloudy day. Although, Andy, is it really going to be a cloudy day? Or is it going to be more of a virtualization day?
I don't know. It's a good question. So in the preparation of this podcast, and you can see that we're actually try to be funny here. So in the preparation of this talk, we started talking about, so what do we talk about today? And cloud obviously is a big topic. And then I challenged Mike and I said, hey, Mike, if you want to talk about cloud, if I hear cloud, I think about EC2, compute, storage. And Mike, you said, what did you say?
So I said that we kind of take IaaS for granted nowadays. I mean, we basically just the fact of the matter is that everybody's going to be using cloud infrastructure in one way or another, whether that be on-prem via VMware and OpenStack, or in the cloud via EC2 or Azure. That really the IaaS is just a fundamental building block of how we build software nowadays. And to a certain extent, I don't even feel like it's even worth mentioning anymore, since it's just a given that it's going to be part of our infrastructure.
So it's commodity.
Correct.
And there are a lot of cool new acronyms now. So Mike has been mentioning IaaS, and he's not just saying a bad word from the South. It's IaaS, which is infrastructure as a service. And I bring these up because there's a lot of these now, right? We have IaaS, PaaS. Is there another, Mike, I think?
Well,
right? There's always been software as a service, right?
Yeah,
SaaS.
Software as a service. Pretty much the marketing folks will generally try to apply the as a service to
Everything.
probably any primary acronym in the
coffee
tech
as a
industry.
service.
Yes.
Right. But
Coffee as a service. Talking to the new stack guys, have been going to conferences with a pancake printer. So I kind of talked to them and said, well, does that make that pancakes as a service?
See, that's a hot idea that you got there. So infrastructure as a service, that's basically what everyone knows as EC2 and all that, where you're just getting the computer or the server. Exactly. And everything else is up to you. So there's a lot more offerings now and a lot more exciting things that we can delve into and use. And I think it's a really kind of, although my personal feeling is that a lot of this is still a little bit in its infancy. It's definitely progressed a lot further than where it is. But there's a lot of cool stuff happening now, and it's just going to get cooler and cooler as time goes on. So it's really good to be aware of all this and think about how it can all be leveraged and pulled into your systems. Because, there's a lot of cool stuff going on. So today we're going to be talking about two of these components, right?
Correct.
And would you like to... So, let's start with the idea of containers. Right? This falls into which section?
So we talk about containers kind of in the context of virtualization, right? Although the interesting thing is that containers are really kind of fundamentally operating at a different level than virtualization. They're actually going to be closer to the bare metal of the machine than a container, if in fact, than a virtual machine, unless of course you're running your containers in a virtual machine, which of course is the way a lot of folks actually deliver those. But, when we start talking about containers, the elephant in the room in the container space is going to be the, Docker, right?
Yep.
So, and as we start to talk about Docker, the main thing you're trying to do there is kind of provide an immutable, repeatable environment in which your software is going to execute.
And so how does this differ then to a traditional Amazon EC2 image? I mean, same thing, right? I have an image. I can run it 50,000 times if I want to, and every time I start it up, it's the same new instance. The idea is that Docker is going to be a lot more lightweight than a full-fledged VM. So you're going to be able to scale a few more Docker containers in an environment versus VMs. The same piece of bare metal, you might be able to get, say, 32 VMs on it, and you might be able to run, 60 Docker containers in that same environment. Right. Because the whole idea is that you don't have to repeat all those fundamental operating system components, and then you're relying on Docker's use of this is actually something that people don't fully grasp, is the fact that Docker is actually taking advantage of components of the Linux kernel that have actually been there for a very long time. And Docker is actually fundamentally replicating some elements that were in, other operating systems, in the early 90s. And so I think basically the main benefit you mentioned in the beginning is speed to delivery, and also more resource friendly, or I'm not sure what the best word, more resource optimized. So you can run more containers faster, meaning bringing them up faster on the same hardware. Yeah, that's awesome. So, and that's what I've heard, and correct me if I'm wrong, but is it still the case that Docker is still seen as more pre-prod testing, CI/CD, or is it ready for prime time production?
Well, it's definitely ready for prime time. I think a lot of the benefits of containerization are going to be more readily apparent in some of the pre-prod environments. Simply because of the whole concept of providing that immutable, the unchanging environment that you're, able to bring up very quickly and then tear down equally as quickly. So some of those benefits are actually, really great in the pre-prod part of your SDLC. But there are definitely, I can't think of any names off the top of my head, but I mean, there's definitely a lot of Docker and prod where you're seeing, very large scale web properties that are running in the containers that are, basically scaled out into the tens of thousands of containers.
Yeah.
And in fact, some of our customers are doing that.
Yeah, I know that. Yeah. And basically, I think the real benefit comes if your application architecture obviously, is built for that. It doesn't make sense if you have your monolith and then you just run it in 50,000 Docker containers, because it's still a monolith and it's just going to run into a lot of issues. So, but new architectures that leverage the fact that they have small components that can be spun up very fast and that can basically fail over very fast to new instances that also come up very fast. That's perfect, right? For that, Docker is just perfect because you can run these instances super fast, super efficient, whether it's in pre-prod or in prod.
Correct. That's exactly correct. And then the whole idea then is that the runtime environment between pre-prod and prod is going to be identical.
Mm-hmm. Right, and that's a really great component of it. I don't know if anyone listening has experimented with Docker at all, but what I've seen in my few experiments so far is, we keep talking about the speed, and just to put that in perspective, if you go on to, let's say you provision a VM, EC2, Azure, wherever you might want to put it, which is, as Andy said, you might have an image that you're just going to deploy to that. You're still talking about maybe 5 to 15 minutes to get that instance up. Whereas Docker, you're as long as you have a place to deploy your container, it's a minute or less even. It's
typically
fast.
it's very close to the time it takes for your process to actually start.
Yeah, it's ridiculously fast. And then the awesome thing about that, especially in these pre-production environments, is you don't have to have necessarily your testing environments up and running and maintained all the time. Right, the development will have everything going and just hand off your new container. You just instantiate that, throw it up, and start hitting it, and then take it down. One of the biggest problems we used to have in my old job was maintaining that environment. And a lot of that comes into the same thing. You could say the same story if you have an image that you're going to deploy on a VM. You get the same kind of benefit, but the speed and ease that Docker provides with that, and it is just really, really beautiful. And the fun part about it, at least for me, because Mike keeps pushing me into this direction, and although I've resisted a little just because it's too much to wrap my head around sometimes, but it's really fun getting back onto the command line.
Yes.
You deploy this, you look really cool. People come by your desk and you have a terminal open, and you're typing in commands and making things happen. Obviously, this can all be automated. If you're in that testing environment, you can even have scripts be part of your script before your test executes. So it's really, really fun in that sense, and it kind of brings you back to getting to the heart of computing, which is moving a little bit more away from the GUI stuff and getting into. Although I think Docker has a GUI interface now, don't they?
Yeah, well, there's when you look at the Docker ecosystem, there's many orchestration tools.
Yeah.
Right. The Docker orchestration tools like Kubernetes and something like a Marathon and Mesos, those are tools that are there to help you deploy containers across multiple machines. And to actually, then work with things like your Docker Compose files, which are, how you bring up multiple interrelated containers. Mm-hmm. So obviously, although, there's a number of different UIs to kind of help make things easier, but, when you're in that pre-prod phase, or especially in the dev phase, you're going to be interacting with that CLI pretty frequently. And, going back to what you said about kind of getting back to the origins of computing, if you will. My wife is always asking me if I'm in the Matrix, right? Because you're watching all the text kind of scrolling by, all the stuff that's kind of going out the standard out with some of the things that you're doing there. So,
well, I think according to Elon Musk, I don't know if you saw recently, I didn't read in depth in the article, but his theory is that we're all part of somebody else's computer game, like The Sims or something.
Yep.
So,
Yep, it's basically, given the advance of computing and things like that, it's inevitable that we'll have the ability to do that ourselves at some point. And then, given that fundamental construct, that in turn, it's almost inevitable that we are in fact, inside somebody else's simulation at this point. And it's actually it's a very long-standing philosophical idea. Some scientists actually, I don't recall their names. Folks can actually Google this offline. But there were a couple of papers that were actually written within the past 2 years where a couple of folks have actually disproved that idea. Like they somehow came up with a proof to prove that we were not, in fact, running in a simulation.
Well, that's because if I punch you in the nose, you'll feel it and you'll bleed. Kind of a theory.
Yeah, well, I mean, if you remember in the Matrix, you could actually punch somebody in the Matrix and they'd bleed in real life.
Yeah, but how do I know they even exist?
Yeah.
Anyway,
I got 2 points now. First of all, would we deploy the whole thing in the cloud? Second of all, how can you offline Google? That's something that I never heard about before. How can you offline? You said Google is offline. How can you Google offline? Anyway, maybe coming back to the cloud and Docker topic.
This reminds me of why Steve Jobs took acid. Okay. Yes, Andy.
Hey, so here's one thing that strikes me, Mike. You mentioned 3 new terms, and I'm sure there's 20,000 more: Mesos, Kubernetes, and the Marathon. And there's so many new tools and so many new frameworks and there's so many new stacks. It feels overwhelming, at least for me sometimes, because it seems every week there's yet another thing that is so cool and sexy right now. And I'm not sure what is really going to stay, what is hype. And what do you say? Is this, I mean, obviously Docker is going to stay. I guess it's not going to go away. What about some of the other frameworks and tools and whatever you want to call them that you just mentioned? Are they all going to be there? Is this something that we need to read up on, or is this something we just wait another year and see what's still left? And what's your take on it?
So I read a really great article the other day, and the URL would be really too long to read within the context of a podcast and expect somebody to type it in. But somebody really described the Docker ecosystem as incestual.
And we'll put a link on the podcast page if you can get that to us.
That'll be great then. So they basically described the whole kind of container ecosystem as incestual because so you have the fundamental construct of the container, and that's Docker, right? Then you have these varying mechanisms for distributing Docker containers across environments, and that's your runtime engine. And that's where you have things like Kubernetes, but then you have competing frameworks like Mesos. So Mesos is a workload orchestration engine that grew out of big data projects. So it was originally intended for supporting analytics jobs that would fire off and disappear, and then they started adding the capability to support long-running jobs. And now in that type of context, something like a Docker container running a web app is actually thought of as just a long-running job, right? And then so basically this article that I read was talking about how all these tools exist, and they all run with or on top of each other. And the fact of the matter is that if you blink, if you feel like you understand an idea of how these tools interact with each other, if you blink, somebody will have figured out a way to flip that around, right? So let's blow everybody's minds real quick. So I have a really well-respected friend, one of the best system architects I ever worked with back when I was a customer. And he left the organization that we were both working at, and through circuitous means, he's now effectively a system engineer at Intel. And what he's doing at Intel is running clusters, and running clusters to support container workloads. Now they were originally running Mesos, and now they've actually migrated to Kubernetes. And in talking with him, I basically wanted to get his take on that. I'm like, so what's your take on just how completely ridiculous the container ecosystem is right now? And he basically pointed me to something called Stackernetes. All right. Now, what Stackernetes is it's a project to run the OpenStack infrastructure components as containers orchestrated by Kubernetes.
Yeah, you're blowing our minds.
So it's just so I honestly
is.
I feel like if I could, have a crystal ball and figure out, where the container ecosystem is in 3 years, I'd be, using a very large sum of money to invest in various organizations. And in 3 years, I wouldn't be talking to you guys again because I'd be sitting on a beach, enjoying a tropical cocktail. So I think it's almost impossible to tell where those container ecosystems are going to go. I personally, my take on it is that the container ecosystem will eventually become a commodity like IaaS.
Mm-hmm.
And then we're going to basically be concerned with platform as a service.
Ah, okay. Yeah, that's a great segue over, because that's basically also in our preparation to the talk was what you were advocating. We were basically saying, well, the whole Docker community, or Docker, is basically stealing the limelight from what you believe is really what we should focus on, which is platform as a service. So now I'm sure we could probably talk more about Docker and containers and whatever they're called, but I guess we should really then focus on platform as a service, because this is the way it seems. And I mean, obviously we trust you and your expertise, and you see the stuff all the time out there. We should probably talk more about the next acronym, PaaS.
But before we get to PaaS, it's time for our trivia.
Oh.
Yeah, so Mike, and just to remind other people in case you haven't been listening to the whole history of our show, I mean, it's only 8 episodes, so you really can go back. And we know we're the most compelling podcast out there, so you should be devoting all of your time to us. Anyway, we do have a trivia component to our show. The winners get their name put up on the podcast, our www.dynatrace.en/pure performance. It's what we call a no prize. Mike, were you ever a comic book reader?
Off and on.
Okay.
Off and on. So I'm super uber nerdy, but for whatever reason, comic books were never my thing. I was basically too busy either creating or breaking the internet. Okay.
Well, we kind of stole the idea from we kind of stole the idea of the prize from Marvel Comics. They had the no prize, NO prize, which you'd get an empty envelope. So this is the KNOW prize. See, nice and clever. So anyway, you basically you just get your name up on the site as the winner. And this week's question, or this episode's question, is from Andy, and it's a very alluring question, at least for me at 9:45 in the morning.
It's a hoppy question. It's a weedy question. It's a yeasty question. So here is, I think all the cool companies now, and I think including Dynatrace, because we are a cool company, are offering things like, beer. What a great invention. Beer for the employees, not obviously at 9 o'clock in the morning instead of coffee to make them drunk and produce some strange code. No, but on Wednesdays, Thursdays, and Fridays in our Waltham office in Massachusetts, we have 2 taps of craft beer. And thanks to our colleague Jeffrey, who is actually very acquainted in the craft beer business, and he has a lot of contacts. He's actually doing also beer festivals in the Boston area. So if you're in the Boston area, you should check that out. Now, here's the thing. The trivia question, which you cannot Google.
Or Bing. I'll play your role this time.
Whatever your favorite search engine. So here's the trivia question. How many gallons of beer has the Dynatrace Waltham office consumed in the last 12 months, knowing that the beer taps are open Wednesdays, Thursdays, and Fridays after 3 p.m. 2 taps in the last 12 months, okay? So it's not Googleable.
Has it been open the last 12 months, or how many months?
It has been open, yeah. So what's we take the average. Let's do it that way. Let's take the average, because the total might be, let's take the average number of gallons per month in the last 12 months.
And is the winner going to be the closest person without going over, or is it just going to be closest period? Is it kind of like a Price is Right? Okay, so closest. So no bidding $1 or 1 gallon.
Exactly.
Okay.
Exactly. Cool. And if you know the answer, then how does this work?
Oh,
Brian?
you will tweet your answer to #PurePerformance@Dynatrace, or you can always, if you want, email it in to pureperformance@dynatrace.com.
Especially if you don't want to give away your guess, basically, right?
Yeah, because then someone might do like one above you, or two, because it's a very compelling prize, right? So we know people are going to be really, really on top of it. So that is the question, and you can always use those avenues to contact us anytime you want. Who's typing there? I hear some typing.
Nobody.
Yeah, that's you, Mike. see, Mike
says nobody.
Yes, Mike is working while we're doing this, everybody. That's the kind of guy he is. He's keeping the matrix alive. So
I'm in the cloud.
He is in the cloud.
Hey, talking about working, can we go back to PaaS?
Exactly. That's where I was going. You stole my thunder.
I'm so sorry.
That's all right. I'm used to it. All right. We're back to PaaS. Go.
So PaaS. Mike.
Yes. So I'm going to babble a little bit more because I think it's a topic that I'm extremely passionate about, and it's something that I find I don't want to say oddly compelling, but I find it really compelling. And the history is really interesting because we look at kind of the development of the public cloud, and I'm going to kind of blow people's minds here for a second. And Microsoft is not always thought of, at least within the past, decade or so, as really leading innovation in an extremely forward-thinking way. But when we look at the growth and development of Azure, Microsoft was actually ahead of the game because Microsoft provided Azure as a PaaS environment before they gave you the ability to utilize it as an IaaS environment. And then when we look at one of the first, relatively successful cloud companies, Heroku was also a PaaS environment that then eventually ended up getting bought by Salesforce for a pretty penny. So some of these early successful cloud companies were actually doing PaaS before they did IaaS. And that's because, sorry.
And was that because the world was not yet ready for PaaS?
I think that's definitely the case. So we look at what some of those environments were fundamentally trying to do is really where we're looking to go again now, here currently or here in the future. And that's, we look at containers kind of stealing the limelight right now. And some of these PaaS environments, for example, Cloud Foundry. Cloud Foundry is kind of my one of the environments that I've been doing a lot of work in since they're very largely prevalent in the enterprise market. And, basically containers are actually a core component of the PaaS. So your applications are still running in containers, but the whole idea here is when you're running a container, you're still responsible for configuring the Tomcat runtime that's going to exist in that container, or whatever other runtime might be present in that container. You're still going to be playing with the JVM heap settings and blah blah blah. So you're still responsible for defining the platform. Now, when we look at platform as a service, what we're actually doing with platform as a service is we don't care about the platform anymore. Our platform as a service is, defining, configuring, standing up that platform for us. All we have to be concerned with is writing our code. Mm-hmm. So there's literally, it's basically, just allowing your business to focus on exactly what it is that makes your business money. Right. And you're not, most of our customers are not in the business of, creating and running platforms. They're in the business of, running their business logic, whether that be, an e-commerce platform, a banking system, whatever that might be, that is the core focus of their business, not Tomcat. Right.
Yeah. But I want to challenge you now on this.
Mm-hmm.
So here's my challenge, or here's my problem with the whole thing. If I'm a developer and I develop my codes, then when I look at my Tomcat, then about 80% or even 90% of the code that actually runs in Tomcat is not my own. I write 10% of the code. 90% is out of my control. But at least I control how I configure Tomcat because I know how to configure Tomcat correctly, because I know what load is coming in. I know which memory, how my application consumes memory. So if I'm also giving up the control of optimizing my PaaS to the PaaS provider, then my dependency is not only 90% to external components, but it's now over 95%. Mm-hmm. So I understand what you're saying, and I think PaaS is beautiful for, especially I think a lot of companies where software engineering is not their first, let's say, discipline, as you say, the insurance companies of the world, even though I'm sure there's a lot of great engineering teams there, but a lot of enterprises, they are not software companies, yet they have to become a software-defined business, and therefore PaaS is beautiful. But it's also, I think, very dangerous because you are giving up a lot of control and you're trusting an entity that does not know how to optimally run your code. Am I right or am I wrong?
So you are exactly correct. And in my opinion, I'm going to actually turn that whole statement on its head. Because in my personal experience, I have yet to meet a developer that actually knows how to run Tomcat in any kind of meaningful way. This coming from a very, very large environment. We were in the very beginnings of this podcast. We were actually talking about some of the test environments and things like that we worked with. And my pre-prod environment was 175 physical machines. My pre-prod environment was probably somewhere on the order of like 6,000 plus cores. Mm-hmm. So, and across that environment, there was, it was extremely difficult to find consistent Tomcat configurations. And as a performance engineer, I was the one that was testing, tuning, and tweaking Tomcat in order to get the code to run. The developers literally had no idea. Mm-hmm. So when we look at what a PaaS does for us, now you look at the key thing to remember here is that when you look at something like a Cloud Foundry, it's an opinionated platform. And what that means is it's basically their way or the highway.
Okay.
So you're basically, you're basically paying your enterprise vendor money because you're going to entrust them to provide a valid configuration for those platform components. Now you can, most of the time there are ways to, kind of adjust things as necessary. Java ops are still, configurable via certain ways and things like that. But the whole idea is that you're no longer setting up a virtual machine. You're no longer installing Tomcat. And in fact, now you don't even necessarily need to really worry about managing configuration, right? Mm-hmm. And when I say managing configuration, I'm saying the deployment and configuration of your APM agents, the deployment and configuration of your database configuration. Mm-hmm. So all of that stuff is being abstracted out as a service. And if your application needs to consume a database, if your application needs to consume an APM agent, you're going to run one command to bind the application to the service that it needs to consume. And then the platform handles all of the under the covers manipulation to enable your application to use that database. Now, obviously, when you're building your application, you're going to be using something like Spring, in order to be able to consume those configuration settings in a meaningful way. But quite frankly, those are the kinds of things that you should be doing anyways.
Yeah. So that's interesting. That means coming actually back to one of the things we talked in the beginning, we have a lot of more as a service. We have, you just said, monitoring as a service, data storage as a service, whatever as a service. So you bind that to your app, and their sole purpose is really to make businesses more efficient by allowing them to focus on what they want to solve, which is the business problem.
Correct. So I want to interject with something, because this is perhaps probably one of the best, most thoughtful things that I've ever heard, and this is something that Ansi Fakuri, I believe like this one of the CTOs at Pivotal, had basically kind of coined a haiku about Cloud Foundry, and the haiku is as follows: "Here is my source code. Run it on the cloud for me. I do not care how."
Mm-hmm. So now I want to segue over and challenge you with another thing, which obviously is dear to all of our hearts, which is performance.
Mm-hmm.
So that means I can write crappy code, and excuse my language, I can write crappy code and still give it to Cloud Foundry, and they just work, and they just make it work, and they just make it scale, and they just make it do wonderful things.
Yep.
Is that what it is? Or what's the price I pay?
No, so the thing is that this is something that that had kind of percolated through the Twitterverse, and I do believe that I've actually received the original information from you, Andy. But when we look at these pipelines across these new environments, if you deploy crap, all you're going to end up with is just 1,000 instances of crap once you get it through these platforms. So you're still fundamentally concerned with a lot of the same paradigms that we've been concerned with for years. It's just as we start to move away from, being dependent upon developers to define, environmental configurations, as we start to abstract that out, you talked about, being responsible for your code, as we start to move to, microservices and things like that, and we start to use Spring Boot, Spring Cloud, your developers are literally only writing the code to represent your business logic.
Mm-hmm. And then
everything else is being abstracted out and being handled by the platform. And if you implement those things in an incorrect way within your business logic, all you're going to do is going to waste a lot of time and resources by requiring your platform to run, perhaps orders of magnitude more instances of a crappy application than you should have, run otherwise.
And basically the price is what you see at the end of the month, or however frequently they bill you at the end of the billing cycle. And you can see, oh my God, it's not $1,000, it's $10,000 to run the whole thing. Yeah.
Correct. And so basically it kind of brings us back to, one of the things that you talk about a lot, Andy, and that I've actually, seen firsthand in my own life. So I like to talk about this as well, and it's the whole fact that these as we're looking to iterate over these development life cycles significantly quicker than we ever had in the past. We need to be looking at these metrics that can actually destroy the environment or just result in really crazy, just completely untenable monthly bills by looking at metrics as early in the life cycle as we can. Mm-hmm. Right, because we don't have the luxury of executing a 4, 6, 8 hour performance test before every release goes out in the prod anymore. That's just not the way we do business anymore.
Yeah.
Let me circle back for a minute here, and one of the common performance issues we see a lot, and Andy brings this one up a lot as well, is perhaps not having enough threads, your max thread count and all that, and when we how does this get handled now in a PaaS situation? Because obviously there are things we can do in the code to try to optimize and maybe use less thread or share them, but there's a wall, and it could be something as simple as a performance solution could be increasing the number of max threads on that instance. How does something like a PaaS, are they just going to throw another instance at you, or is there a control to say, okay, no, we'll give you more threads on that instance?
So a lot of those things are configurable fundamentally as you really dive into the guts of how those things are kind of put together. I mean, because the reality of the situation is that there's, a Tomcat or a WAS instance under the covers. But typically what you're relying on here, once again, since you are using something like a container, right, the under the covers, the PaaS is actually managing that container environment for you. What you're looking to do here is you're looking to actually scale the environment out by increasing the number of app instances. So you're designing your application in such a way that there's minimal persistence, and that persistence is actually handled outside of your application runtime. And the whole idea then is that as your application needs to grow, you're going to scale that application out horizontally. And then the ideal situation is that your application can scale the fundamental building blocks of the application to be able to scale those independently.
Mm-hmm. So. But coming back to, so it's amazing. I mean, I think amazing things will happen, and I think we will see a lot of software-defined businesses that may not have, let's say, they don't want to spend the resources on actually figuring out everything on their own. They just want to build the business logic. They can do a lot of cool things. They can fulfill, I would always say, as the promise of continuous delivery, the promise of DevOps, deploying fast and building scalable apps. But the critical thing is, what we have always been promoting is monitoring every single change that you're pushing through the pipeline. And now, not only looking at performance, which has always been one thing that APM tools and we in Dynatrace have done pretty well, but it's not only about performance, but it's about architectural validation. It's about like how many database queries do I make, how often do I call the service, but also how many resources do I consume, meaning how many CPU cycles, how much memory do I allocate, how many log statements do I write to disk, and how many bytes do I send over the wire. Because if we monitor all of these metrics early on, then we can immediately say, hey, this code commit that developer Joe is trying to commit is going to increase CPU consumption by 10%, which means we need 10%, or the platform will eventually provision 10% more compute power underneath the hood to compensate for that, right?
Yep.
And so we need to stop this early on, and that's why we are such a big proponent of making sure that you do metrics-driven continuous delivery, looking at the metrics early on, because if you just start monitoring in production and you find out, the latest deployment is now eating up our margin for our platform that we built, we're actually not making money anymore, but we pay too much, then it's too late. And you may need to revert a lot of changes that the engineers did, that they pushed in the last sprint, that are hard to revert, that mean a lot of effort. So metrics-driven continuous delivery. And Brian, we two talked about this as well. I think in episode 3, if I believe, we talked about performance testing and continuous delivery, performance testing and continuous integration, but it's more than just looking at performance from a response time perspective. It is very much so from a resource consumption and a cost perspective in the end. Because if you are allowing developers that, and hopefully I don't offend anybody, but if you allow developers that don't really have that don't know what's actually going on in the architecture or in the platform itself, and they just write code, if they don't know what cost impact that code change actually has, we allow them to deploy change that potentially destroys the whole business model of their organization.
Yeah, I think this also, back on that episode, a lot more in context of infrastructure as a service. We talked a lot about this stuff does come back to bite you in your bill at the end of the month, right? And I think whether or not you're talking IaaS or PaaS or any of the others, you still have to monitor all the same metrics that we've been talking about, because it's still going to end up billing to something.
Monitor all of the things.
Yeah, it doesn't change what you have to pay attention to, right? So in this case, it's not like, if we're using platform as a service now, we can start ignoring certain components. Not at all. In fact, I guess they're all equal. You have to always be monitoring those, because there's going to be a charge there somewhere.
And I think what I want to stress, and I know that, there's a lot of tools out there in our space, but if a feature that I'm implementing as a developer is performing in sub-milliseconds. But if I increase that with a code change from sub-milliseconds, if I just increase it by 50%, but if I know that this feature is used 1,000,000 times every hour, that's going to be a lot of impact. And that's why it's so important. And that's what I think that's what we stress all the time. That's why we are so hard on the fact that we have every single transaction all the time. We have our PurePath technology where we trace fast, slow, failing, good transactions. But what we really identify is regressions from code commit to code commit. And these regressions can be, yes, performance related, but more so, especially in the PaaS world, I believe, and Mike, if I get you right, more so about resource changes, resource consumption changes, and also architectural changes. And
Correct.
like call pattern changes. I wrote some blogs about bad call patterns in microservice architectures, the N+1 query problem that we traditionally saw between app server and the database, then later saw between the browser and the front and the web server, and now we see it between caller and callee in a microservice architecture where you end up, because of a bad coding practice, instead of making one smart web service call to the back end, you make the N+1 query call pattern where you are, depending on your result set, make 10 calls, 100, 1,000 calls, and that adds up and then costs in the end.
Yeah, one of the things that always amazes me, and I actually personally, Andy, I love, well, I don't love that observation, but I find it almost embarrassing that the more new pieces of technology that we have, the more we keep seeing people make the same mistakes again, right? We learn through a mistake with, two pieces of architecture talking to each other, and then we deploy two new pieces of architecture, and somehow we've completely forgotten what we learned about the two other pieces.
Yeah, that's human nature.
Right. I just find that fundamentally just I don't know if I want to say baffling, but it's something that's always kind of amazed me, and it's something that I've always taken on the road with me when I go talk to people is we have all these new pieces of technology, but we're still making the same mistakes that we've been making for the past 20 years.
Well, and that's why we'll never be on a Starship Enterprise exploring deep space. We'll end up destroying ourselves instead because we make the same mistakes over and over.
Yeah. They'll have used fundamentally wrong metrics for measuring distance. They'll use inches in one part of the system and in millimeters in another. And,
that will never happen. Come on, really?
I do want to. We are just about out of time. I do want to bring up though that Andy's point about the the few milliseconds or sub-milliseconds or even really turns this into a call out to the performance engineers, right? Because if we're talking about, and again, I don't mean I'm saying this in any kind of an offensive way, but if we're dumbing down development to just strictly the business logic even more, right? That's going to mean developers are going to be paying a lot more attention just to that business logic. There's a chance they might not be looking at the bigger picture as much, and they in their CI environments might not notice or think about a 50% increase in a sub-millisecond response time. And this is where it comes to those performance teams to really make sure they're looking at this data, because they're now going to be the gatekeeper, because they're going to see that function is called 500,000 times in a second, which then adds up that piece. So it's really a wake-up call to say, start besides testing and looking at the stuff, life cycle. Really, the performance teams really have to dive in deep on these metrics and track them to be able to translate and bring it back, because they're going to be the ones that see this under load, that see the real impact of this, and can prevent it from going out into production.
Yep. And so I'm gonna kind of leave on a interesting statement that I made at our Perform conference when I was talking to the guys from Perf Bytes. And not to mention an alternative podcast in the context of yours, but
Perf Bytes is responsible for us starting this one.
Oh, awesome!
Our good friend Mark Tomlinson pushed us to do this. So
sweet. So I was talking to the Perf Bytes guys, and one of the things that I mentioned is, at that point in time, last year, there was a quote kind of floating around that it was inhumane to not do DevOps. Because by following the DevOps best practices and things like that, for a lot of these organizations and folks, you're actually starting to give people their personal time back, right? Mm-hmm. And I went on record saying that, you know, not only is it's so we can kind of sort of start to accept as given that it's inhumane to not do DevOps. And then my take on that was it was inhumane to do DevOps without performance metrics in your pipeline, because you're just compounding all of those issues that you would have had in a more traditional environment. You're taking that same death by paper cut, and now you're applying that to your releases as well. And I know that in my personal history, having formerly been out in the wild, when I had 13 different agile teams all filtering builds into me, in order to scale my efforts and my expertise, I had to teach people to fish. And then additionally, if I had $1 for every build that I received in my history of being a performance engineer, if I had $1 for every build that I received that was just fundamentally garbage and was easily identified as such in the script recording phase, I probably wouldn't need to be working anymore. You know, going back to that comment that I made earlier about possibly enjoying a cocktail on the beach for the remainder of my existence. You know, if you have some sort of release that has a 120 millisecond non-functional requirement for a key transaction, and when you're recording a script and it's taking 12,000 milliseconds, the old excuse from the developer saying, "Oh, well, I thought it would work better in your environment," that just doesn't fly anymore, because every single thing that we've done as a part of implementing DevOps correctly is to try and ensure that those environments are as identical as possible. There's been a lot of talk lately even about, doing things to make test data significantly more replicated across environments and things like that. So those old excuses just don't fly anymore. And those old problem patterns or anti-patterns, as we like to call them, are just significantly more impactful, just because, once again, those old standard problems that keep happening are just now even more impactful. And the problem patterns actually then extend themselves. That death by paper cut is actually happening with your releases as well. So if you waste an hour of time on every release and you have 1,500 releases, well, you've just wasted 1,500 hours and you've almost wasted an entire man year.
Wow.
Excellent. Well, the only thing I'd counter to that is it's not going to give people their life back. They'll just get more work in the pipeline.
Oh yeah,
it won't be as stressful, but they'll.
Hey, I want to say, Mike. Wow, I think we need to actually invite you back to another show, and I'm sure there's a lot of topics we can find to talk about. Brian, do you want to, or shall I start with my wrap up? What I learned.
Yeah. I think I already did mine before Mike. So please go ahead.
Okay. So I think what I just learned is that PaaS is the next big thing, even in case it is not already the big thing. And what I just learned is that we allow a lot of developers to focus on their business logic, which is great, but that performance monitoring, but extending it from response time to resources to costs to architectural patterns is more important than ever, because you're going to kill all your benefits later on if you're making mistakes, and if you not monitor with every commit, then it might be too late and it might be too cumbersome to actually fix the stuff that you've committed days or weeks ago. So that's why I encourage everyone to also read up a little bit and watch some of the videos that I put on YouTube on the Online Performance Clinic channel. It's bit.ly/DT tutorials. I have a session on metrics-driven continuous delivery where I actually cover how this works in a Dynatrace environment, where I also show how you can get Dynatrace for free, registering for the free trial, and then using it as a personal license for life to actually make sure that you're not committing any bad code changes. I think we need to start where it starts at the beginning, and that's the IDE and the developer. We want to empower developers with detecting regressions on these metrics. So please have a look at what we have to say.
Yeah.
All right.
I'll put a link to that resource you mentioned on the page.
Cool.
And
Cool.
And what you just said just kind of brought in a thought in my head. It's the same old new, right? It's everything we're talking about, the metrics, same metrics, everything else is just something new on top of. So whether it's PaaS or whatever the next new thing is going to be, definitely it's important and interesting to learn what those new components are and how they're being utilized and what benefits they can offer, but you still have to monitor and manage it the same way. It hasn't, at least so far, nothing has really changed the fundamentals of what developers and performance teams have to do, and even operations to ensure that it is a cost-effective solution and a really good performing one.
I concur.
All right. And are there going to be, besides on the dance floor, any appearances after July 19th?
Yeah, I hope so. I hope in the DevOps Days in Boston and Chicago, that's on my list. And I believe in September we have, what do we have in September? I think it's Star West, if I'm not mistaken. We started in October already. I believe it is. Oh, Java 1 is coming up in September. That's quite a way out. And Star West, the first week of October.
So I'll be at the Spring One Platform Conference in Las Vegas. Obviously the speaking slot or whatever isn't necessarily ironed out yet, but Donna Trace is going to have a presence there.
Excellent. All right, and if there's nothing else, then I will say goodbye for episode 8. Thank you everybody for listening.
Thank you.
Thanks for having me on, guys.
Thank you for being on, Mike. It was a pleasure. Great conversation today.
Bye-bye.
Goodbye, everyone.
Awesome.